How do you go for finding out the impactful variables for developing a model?
So there are multiple ways of finding the impactful variables. In regression, in logistic regression, you can directly use a technique called p-value. You can use that p-value measure. It will tell you if the p-value is less than 0.05, that variable is impactful. If you come to decision tree model, you can use something called information gain that will tell us whether a variable is impactful on the target variable or not. If we see some other little advanced techniques, maybe information value, IV, can be calculated, weight of evidence information value can also be used for detecting whether a variable is impactful or not. The simplest way is if you're working on a regression problem, you can directly calculate the correlation coefficient. If that correlation coefficient value is high, that variable is impactful.
So what is the difference between random forest and single decision tree?
So random forest, as the name suggests, it's a collection of multiple trees. Random forest is an ensemble technique where we build multiple decision trees and we collate the results to get us a better predicted value. A single decision tree compared to a random forest, as the name suggests, a single decision tree is one tree, whereas random forest, multiple trees. The major difference is a single decision tree may not be able to capture all the patterns in the data. It may lose out some of the patterns, but a random forest has a better ability to capture all the patterns in the data. In general, usually 2 to 3% lift in the accuracy, definitely you will see with the same data if you're using a random forest model when you compare it with decision tree. Sometimes it is also observed that the accuracy when you do a random forest is much higher compared to a decision tree.
Have you worked in deep learning projects?
In my 4 years experience in banking, most of the times I have been working with logistic regression and decision trees. Recently, we started exploring these ensemble models. Honestly, I never worked on any of the practical deep learning projects, but out of my own interest, I have read few things about TensorFlow. I have I watched some of the YouTube videos on convolution neural networks, etc. But honestly, in my projects, I never worked on deep learning.
So I understand out of interest you have learned deep learning through different channels. So you said about CNN. Could you please tell me what is CNN algorithm and where more extensively we are using it?
So CNN stands for convolution neural networks. Basically, it is mostly used for image processing problems. So CNN is a special case of ANN, artificial neural network. So in artificial neural network, you have something called a hidden layer. In convolution neural network, there's a new concept that has been introduced, which is known as convolution layer. So in artificial neural network, directly, like suppose if you are analyzing images, if you want to do object classification, I give you the image of a cat, I give you the image of road, I give you the image of tree, I give you the image of pedestrian. Maybe by using this model, I can build a model that will predict which side is road. We can use it in a self-driving car. Okay. The CNN model will help us in identifying or in classifying these objects, whether it is a tree or not, whether it is a cat or not, whether it is a car or not. So we take those image pixel values as input. Directly taking those pixel values, we cannot directly operate with them. So we detect the features. A car has a different set of features, the image of a car. The image of a tree has different set of features. The image of a cat has different set of features. Maybe if you take the color grading, cats might be mostly in black, white, or gray shades. If you take trees, they might be mostly in brown and your green shade. If you take cars, they may be in red or some black shades. Okay, those are some of the features that are there in those images. Like that, there are several other features. Maybe cat has smooth curves, whereas car has sharp lines. So you can capture all those features by using something called kernel matrix. That is a core concept of convolution neural network. So by using those features, we'll be able to easily predict whether a particular image is cat or car or a pedestrian. So that is the convolution neural network briefly.
Okay, so Venkat, what are the various steps we follow to develop a machine learning project?
So largely, I would say like it's not really followed in every company, but based on the projects that I have worked on, I can give you my experience. Largely, we can divide them into 6 steps. Step number 1, phase 1 is what is the objective? In phase 1, we mostly it involves a lot of stakeholders, it involves a lot of higher management where they sit and decide what is the final objective. I want to build a machine learning model. What is my objective? I want to build a model to predict the sales. I want to build a model to predict the number of defaulters. I want to build a model to predict whether this particular transaction is fraudulent or not. So deciding the objective, setting the goal, that is phase 1. After phase 1, once we decide what is our objective, to fulfill that objective, we start phase 2. What is it? Phase 2 is data collection. You collect the data. You want to predict sales, collect the data related to sales. You want to predict whether customer is defaulter or non-defaulter, collect the data related to that. So phase 2 is data collection, data exploration. You collected the data. Sometimes we may have to buy the data from bureaus. Sometimes we may have to buy the data from market research companies. Sometimes we may have to scrape the websites to get the data. So once you collect the data, explore the data, validate the data. So once you collect the data, data exploration, after that, the third phase is data validation. Find out whether there are any outliers, find out whether there are any missing values, validate the data. Is the data falling in our limits? Is it making sense based on our business context? Then once you find all those issues, clean the data, prepare it for analysis. We cannot take raw data and go for model building. So objective setting followed by data exploration, data validation, data cleaning. These are the three phases. And then the fourth phase is machine learning model building based on the data, based on the objective. What is the best model? Is it a regression that we have to build? Is it logistic regression? Is it decision tree segmentation that we want to build? That is a fourth phase, machine learning model building. And then the model validation. Usually we validate the model while building the model itself. Like if we want to strictly validate, do the in-time validation, out-of-time validation, making sure that the model is working not only on the data that is in our hand, but all the data sets that are similar to it so that it can work well in future as well. And finally, model deployment. So I would say there are 6 phases, starting from setting of the objective, data collection, exploration, data cleaning, preparing for analysis, model building, model validation, model deployment. My experience generally, most of the times I spend my time on phase 2, data exploration, phase 3, data validation cleaning, phase 4, model building, phase 5, model validation. I did not get a chance to work on model deployment. Usually the company that I have worked with, there is a separate team that takes care of model deployment.
What is the objective of splitting a data into test and training data sets?
Imagine we are building a machine learning model. I have a data set, I have a single data set, overall data. If we are building a machine learning model on the overall data itself, and the model is giving me, let's say, 90% accuracy. Now, what is the guarantee that this model will give the same 90% accuracy in future? What is the guarantee that this model will give me the same 90% accuracy on a data set which is coming from the same population? So to defend our model or to avoid overfitting, maybe the model is learning everything from this particular data. It's working well only on this data set. To defend that model or to tell my model is really good, we have to do the validation. So usually what we do is we take the overall data, randomly take 80% of it, call it as trained data, build the model, take the remaining 20% of the data, call it as test data, validate the model on it. Or if we want to do it extensively in a better manner, we can take the overall data, take 70% of it, use it for model building, use 15% of it as test data, use 15% of it as validation data, making sure that the model is working well on the trained data, test data, validation data. If the model is giving, let's say, 90% accuracy on these 3 data sets, then whichever data that comes from the same population, the model will definitely give better or the same accuracy, better in the sense, the same accuracy that it is showing right now.